Hey guys, welcome back to another Algebra 1 lesson. Today we're going to look at simplifying radical expressions. So with some radical expressions, we're going to look at the product property of square roots and the quotient property of square roots. What the product property says, if I have the square root of two things that are multiplied together, like let's say the square root of a times b, I can rewrite that and say, well, that's nothing more than the square root of a times the square root of b, or vice versa. If I have the square root of a times b, I can multiply those together and say that's the square root of whatever that product is. Same thing works with quotient. Remember, quotient is division. If I have the division of a and b, and I'm taking the square root of that, that's nothing more than taking the square root of a and dividing that by the square root of b. And we're going to look at some examples here, and you'll understand why this property is handy to know and to use when trying to simplify some of these radical expressions. I went ahead and I listed the first 15 perfect squares. I encourage you to memorize these. You're going to see these over and over again, and it's good to realize that they're perfect squares. This is 1 squared is 1, 2 squared is 4, 3 squared is 9, 5 squared is 25, 15 squared is 225. So all of these numbers are perfect squares. That means if I take the square root of them, I get a whole number. So looking at 72, I want to take the square root of it. Well, if I look at this list, it's not on my perfect square list. I realize that it's going to fall somewhere between um, 8 squared and 9 squared. So if I'm thinking on the number line, I know the square root of 72 is somewhere between 8 and 9, but I want to simplify this and let's think about it. Well, when I'm simplifying them, what I like to do is I like to break it down and look at all of the multiples of 72. So my multiples of 72 are obviously 1 and 72. We've got 2 and 36. 3, and you could just sit here and punch this in the calculator and keep coming up with these. 72 divided by 3 is 24. 72 divided by 4 is 18, and we could just keep on going. I don't need to go any further because I see that 36 is a perfect square. 36 is a perfect square. So I'm going to rewrite this then as the product of 36 times 2, right? 36 times 2, we just decided, was 72. And the reason that I want to do this is because if I rewrite it as the square root of 36 times the square root of 2, well, what is the square root of 36? We know that is 6. So this simplifies to 6 square root of 2. This is this radical in simplified form. Okay, so let's look at the square root of 5 times the square root of 48. Well, we can think about this. Let's just go ahead and multiply. What is 5 times 48? And we get 240. Now let's see if we can break 240 down. 240 divided by 2 is what? 120. 240 divided by 3 would be 80. 240 divided by 4, 4 is a perfect square. That's 60, but that's not a very big perfect square, is it? 240 divided by 5 would be 48. Oh, I shouldn't even, didn't even need to type that one, did I? It's right here. 240 divided by 6 would be 40. We can just keep on going. I'm going to pause it while I write all these out. All right, so I've listed the factors of 240, and the very last one I listed has a perfect square. And we said that, were any of the rest of them perfect squares? Oh, yeah, the 4 is a perfect square. So we want to go with the one that is the highest. So obviously 16 is the highest. So I'm going to rewrite this as the square root of 16 times the square root of 15. The square root of 16 is 4. So in simplified format, this is 4 square root of 15. There it is. We could have left it like this and broke 48 down into the square root of 16 times the square root of 3. We can see that that's 4. So we have 4 times square root of 3 times square root of 5. We can put those two together and we get 4 square root of 15. I don't care which way you do it, as long as you realize this is like applying the commutative property. We can multiply things in different order. It doesn't matter which one we do first. We're multiplying all these things together, and in the end, we get the same answer. All right, so let's look at 24 divided by 27. Square root of 24 over the square root of 27. Well, I know that 27 is divisible by 9, and I know that 9 is a perfect square, so I want to use that. I know that 24 is divisible by 4, and it's a perfect square, so I want to use 4 and 6. So square root of 4 is 2, so I have 2 square root of 6. Square root of 9 is 3, divided by 3, square root of 3. And there is my answer, because the square root of 9 is 3. That's where this 3 came from. And then I just kept the square root of 3. This 2 came from taking the square root of 4. So now let's try simplifying it with variables. Remember, there's nothing written here, but this is understood to be a 2, right? This is 525. I'm looking for what number can I multiply by itself to give me 525. So we're going to think about that for a minute, and then we're going to go through here and break all of these down so that we can look at how many 2's there are in there. How many times is it being multiplied by itself twice? And we're going to pull those out. Okay, so let's think about this for a minute. 525, I'm assuming, is divisible by 25. It is. It's divisible by 25 and 21. 25 times 21 is 525. So I'm going to rewrite this as 25 times 21. And I'm going to rewrite x to the 4th as x squared times x squared. And then I'm going to rewrite y to the 5th as y squared times times y, right? 2, 4, 5. And same thing with z. Z squared times z squared. We'll put lines through these so we know they're z's, times z to the 1st. And this 25, I'm going to go ahead and rewrite it as 5 squared. It's the same thing, right? 25 is 5 squared. Okay, so now all of these squared and square roots are going to cancel each other out. That's in like inverse operations. So I'm left with 5. The square and this square is going to cancel. X, X, Y, Y. So I've taken care of this one, taken care of this, taken care of this, taken care of this and this. Now a Z and another Z, I can pull them out. And what's left under my radical symbol that I couldn't pull out? We're left with 21. We're left with a y, and we are left with a z. So going ahead and writing this now in simplified version, x times x is the same as x squared. Y times y is the same as y squared. We've got a z squared, and then we've got the square root of 21yz. So this is simplified radical form. Okay, let's try 147. I encourage you to pause the video and try this on your own. Okay, I've rewritten it here. 49 is the same. If I take the square root of 49, I get 7. Take the square root of x squared, I get x. So I'm done with this, done with this. Square root of y squared is y. Square root of another y squared is another y, so I've got 2 of them. Square root of z squared is z, and I've got it a second time, so I'm going to have z squared out here. And then inside I'm left with 3xz. So it simplifies to 7x y squared z squared times the square root of 3xz. All right, so let's write and solve a radical equation. It says Sarah uses an online calculator to determine how much interest she would accrue in a savings account after 2 years. She plans to invest $750, and the calculator determines that she could have $780 after 2 years. Find the interest rate given the formula. So we have A is the amount after 2 years. P is the principal investment. So she has 780, it says, after 2 years. I don't know what's happening here. And let's see, 780 after 2 years. The initial amount that she invested, the principal amount, is 750. We're going to take the square root of that, and then we're going to subtract 1, and that gives us our rate. So let's try this problem. Let's simplify 780 divided by 750. 780 over 750 will reduce to 26 over 25. So I'm just going to rewrite it as the square root of 26 divided by the square root of 25 because I know the square root of 25 is 5. So I've got the square root of 26 divided by 5 minus 1. So if we want, I mean, we're trying to find the interest rate here. We can just type this in the calculator. Square root of 26 divided by 5 minus 1 gives me 0.0198. So this equals, let's write it over here, 0.0198. So we know that's really close to 0.02. If we're talking percent interest, this is the rate. So if we're going to write it as a percentage, we move it over 2 places. So this is a rate of 2%. So roughly the interest rate, or we would say approximately, the interest rate is 2%. All right, that is all I have for this video. I hope this made sense. Again, if you have questions, reach out and let me know. Have a great day, guys.